Imagine the smartest student in the world. They have read every book, every article, every website on the internet. Their knowledge is absolutely incredible. But when you ask them a simple question, they do not actually answer you. Instead, they just keep talking, predicting what words come next, like they are trying to finish a sentence rather than help a person. That was GPT-3 in 2020. OpenAI had built something remarkable, a model trained on hundreds of billions of words from the internet. It could write poetry, summarize articles, and answer trivia. But it had a fundamental problem. It was not trained to be helpful, it was trained to predict text. And those two things, it turns out, are very different. Here is the core problem. When GPT-3 was trained, it was given a simple job. Look at a piece of text and predict what word comes next. Do this billions of times across billions of sentences, and you learn an enormous amount about language and the world. But predicting the next word is not the same as being a good assistant. A good assistant understands what you actually want. They know when to be brief, when to be detailed, when to say no. They do not just continue your sentence like a search engine autocomplete. The researchers at OpenAI call this the alignment problem. The model's goal, completing text, was not aligned with the human's goal, getting genuinely useful help, and fixing this would require an entirely new kind of training. The OpenAI team came up with a three-step recipe to fix this. They called it reinforcement learning from human feedback, or RLHF. Do not worry about that name for now. By the end of this video, it will make complete sense. Think of it like training a new employee. First, you sit with them and show them exactly how you want things done. Then you hire a judge who watches their work and scores it. Finally, the employee practices over and over, trying to get higher and higher scores from the judge. That is almost exactly what OpenAI did with GPT-3 to create what eventually became ChatGPT. Let us go through each step one by one. Step 1 is called Supervised Fine Tuning, or SFT. OpenAI hired a team of human labelers, real people whose job was to write ideal responses to thousands of different prompts. Things like explain what a black hole is to a kid, write a cover letter for a software job, summarize this news article. For each prompt, a human wrote the perfect answer. Then they fed all of these human demonstrations into GPT-3 and said, learn from these, copy this style. This is what a helpful response looks like. They did this for about 13,000 different prompts. After this step, the model got noticeably better at following instructions, but it still was not perfect. The model could only be as good as the examples it had seen. What if someone asked something new? Here's the problem with just copying from examples. The world has infinite possible questions and situations. You cannot write a perfect human demonstration for all of them. And sometimes two different human labelers would disagree on what the best answer even is. One person might prefer a short, crisp response, another might want more detail. So the model ends up averaging across all these opinions, which leads to bland, safe, average answers. OpenAI needed a way to teach the model not just what good answers look like, but what makes an answer good in the first place. So they moved to step 2. Step 2 is where things get clever. Instead of asking humans to write perfect responses, OpenAI asked them to do something much easier: rank responses. Take a prompt, generate 4 different responses using the model from step 1, and simply ask a human which of these is best, which is second best, and so on. Ranking is much easier than writing from scratch. You do not need to know how to write a great essay to know which of two essays is better. OpenAI collected about 33,000 of these human rankings. Then they trained a completely separate, smaller model on these rankings. This model learned one job and one job only: look at a response and predict how a human would rate it. They call this the reward model. Think of it as a judge who has learned human taste. What exactly does the reward model learn? Through seeing tens of thousands of human rankings, it absorbs a sense of quality. It learns that a good response actually answers what was asked. It learns that being too long or too short both lose points. It learns that confidently stating wrong information is worse than admitting uncertainty. It learns that tone matters. Overly formal or overly casual responses score lower. None of this was programmed explicitly. The model figured it all out by studying human preferences. Now, OpenAI had a judge that could score any response instantly, without needing a human in the loop. This is the key that unlocks step 3. Step 3 is where the real magic happens. The model from step 1, a student who learned from human demonstrations, now practices generating responses over and over again. For each practiced response, a reward model judge gives it a score. The model then adjusts itself to try to get a higher score next time. This loop, generate, score, adjust, repeat, runs millions of times. The technical name for this process is proximal policy optimization or PPO. The word proximal just means nearby or close. The key constraint is this: the model is not allowed to change too drastically in any single step. Without this constraint, the model might discover a weird hack that scores highly but is completely useless. For example, it might learn to output extremely long responses because the judge slightly favors detailed answers. The proximal constraint keeps it honest. Here's one of the most surprising findings in the entire paper. After training InstructGPT using these three steps, OpenAI ran an experiment. They asked human evaluators to compare responses from the original 175 billion parameter GPT-3 against responses from InstructGPT, but InstructGPT was trained at only 1.3 billion parameters. That is 100 times smaller. And the result? People preferred InstructGPT 85% of the time. A model that is 100 times smaller just because it was trained to be helpful rather than just to predict text. This was a stunning demonstration that alignment, teaching a model the right goal, matters far more than just making it bigger. Raw intelligence without direction is nearly useless. Nothing comes for free. When OpenAI measured InstructGPT on standard academic benchmarks, the kinds of tests used to rank AI models on leaderboards, they noticed something concerning. InstructGPT scored slightly worse than the original GPT-3 on some of these tests. The researchers call this the alignment tax. By teaching the model to be helpful and safe, it lost a little of its raw performance on academic tasks. Think about it like this: a professor who knows everything might score perfectly on every exam, but they might be terrible at actually explaining things to students. Training them to be a better teacher makes them more useful in the real world, but might cost a few points on an abstract test. OpenAI considered this trade off completely worth it, and they found ways to reduce this tax over time. InstructGPT was released in January 2022, but you probably know it by a different name. Just 10 months later, in November 2022, OpenAI launched ChatGPT. ChatGPT was essentially InstructGPT with a polished conversational interface, additional safety tuning, and a new name designed for the public. Within 5 days, it had a million users. Within 2 months, 100 million. It became the fastest growing product in internet history. And at its heart was this same three step recipe: human demonstrations, a reward model, and reinforcement learning. Every major AI assistant today, Claude, Gemini, Copilot, uses some version of this same approach. InstructGPT did not just build a better chatbot, it established the blueprint for how to align powerful AI with human values. Let us zoom out for a moment. Why does any of this matter beyond making a better chatbot? Here is the deeper point. As AI systems become more powerful, the gap between what they are optimized for and what humans actually want becomes more dangerous. A superintelligent model that is very good at predicting text might find all sorts of ways to technically complete its objective while being completely useless or even harmful to humans. Alignment research, the field that InstructGPT helped launch, is about closing that gap. Teaching AI systems not just to be capable, but to be beneficial, to do what you actually mean, not just what you literally said. InstructGPT was a small but crucial step in this direction. It proved that the gap could be closed and gave researchers a practical toolkit to do it. InstructGPT opened a door. Researchers quickly started building on its ideas. Anthropic developed constitutional AI, where the model learns to critique and revise its own responses using a set of written principles, reducing the need for as many human labelers. Others explored replacing human feedback entirely with AI feedback, making the process faster and cheaper. But the hardest challenge is still ahead. Right now, humans can judge whether an AI response is good or bad. But as AI systems become more capable than humans in specific domains, how do you evaluate them? How do you give feedback on a response that you cannot fully understand yourself? This is the open research problem called scalable oversight, and it might be the most important question in all of AI. If you want to go deeper on any of these ideas, RLHF, constitutional AI, or how DeepSeek R1 took this even further with pure reinforcement learning, those are exactly the videos coming next on this channel.